Welcome to Practical Enterprise AI, where we'll be sharing a little bit about common roadblocks to implementing AI and how to avoid them.
I'm Julian Grunauer. I'm a technology strategy engineer on the CTO team.
And I'm Alex Yu. I'm one of the senior product engineer on the product strategy team as well. So you've all heard about AI, you know how it's popular, but then implementing it is always harder than it seems. I'm sure everyone here has faced many issues when implementing AI in practice. Maybe it has outputs that you're not expecting. Maybe it's hard to benchmark. Maybe you have security concerns. So today we'll be talking a little bit about these various different categories of roadblocks to actually reaching a production implementation of enterprise AI, as well as some potential solutions and ways to think about these problems.
So quick overview of what we're going to be going through today. First of all, security. We all deal with it. How does Appian think about security and AI? Fine-tuning. Is it necessary? How do you do it? It's complex. It's hard to build out. You need a team of engineers usually to actually build these models and actually benchmark them and maintain them. And then AI choice overload. We've been hearing a lot about AI this year. And when I say a lot, I'm sure we're all very sick of hearing a lot about AI. So how do you choose? How do you figure out what's real, what's just promises? And then finally, enterprise sprawl. I'm sure we're all familiar with large applications filled with dozens of pages, objects, actions. How can we use AI to actually manage a lot of this load? And at the end, we're probably going to end with a brief little Q&A. So save your questions for the very end of the presentation. We're happy to get to them.
So the elephant in the room is security. I'm sure everyone has thought about it because it is top of mind. Who has access to data? Are they pre-training or retraining the LLM on our data? Well, that's actually just table stakes. Most AI providers or LLM providers don't train on your data that you provide them. That's just basic data privacy. Where it lives, usually some bolted down environment. Most providers have this. But where the differentiators between these products usually come in is in data access and data leakage. Data access is about who has access to what data, where you have control over what the AI is putting out. In some cases, it's because the AI might know information that a certain customer may not have the permission to know about. It can leak that in certain situations. You'll see that in the next few slides. This is an example of what's called jailbreaking. The idea that prompts can be provided to the LLM that cause the LLM to not notice that it is something that it should not say, even if you had guardrails in place. So a lot of times, providers say that, oh, we have X, Y, or Z guardrails against certain negative prompts or illegal prompts. Well, those can sometimes be broken around. It's not a 100% chance that your LLM will recognize that this is harmful and respond accordingly. And you'll see that in the example, it actually ends up giving extremely dangerous advice. So by seeing this, this opens up the door for internal risk. And internal risk makes up a huge part of every company's risk profile. By Verizon, 60% of all cyber attacks are caused by insiders. And these insiders are the folks with the information. It's really hard to determine who should and who should not have that information. And that's where your ability to define and define easily who has access to what is very important. There's so many stories that I hear of companies where an employee has been offboarded for 6 months and then their account suddenly goes back online and they already have access to everything that you already have. So what kind of system can allow you to go in and very quickly or in an automated way offboard employees or only give you permissions during the times that you need it? And the way to look at this is actually the way you look at access control as a problem in general, right? The three things that we really care about is data privacy, data access, data leakage, but that is parallel to physical controls where people do not have physical access to the data. The technical control, such as firewalls and ensuring that there's proper authentication. And then these administrative controls. And the administrative controls is what you really can control when selecting a product that provides you generative AI. Those administrative controls ultimately allow you to also audit who you've given permission to what information that the Gen AI has provided. And that's where our approach to row level control comes from. And we're making investments in making that even more robust and even more fine-grained, such that you can monitor specific fields that customers have access to. In this case, let's say that you have some data in Oracle that you do not want everyone to have access to, or maybe Salesforce. Say in Salesforce, only salespeople in a certain region is able to access data in their region. Then when looking up your information about all your customers on your home page, right, within your Appian application or within any other application, we enforce that you only see the rows that are in your region based off of the rule that you defined. And this can also extrapolate to individual columns and every single separate data source that you have. And we'll apply these in real time when it's queried. And the best part is that the way we implement GenAI uses your permissions when querying this data fabric, so that it only knows about what you know about, so that there's zero chance of that leakage. And that really brings us to fine-tuning, right? Where fine-tuning is the biggest source of that leakage. Everybody says, oh, we should fine-tune on our data, we should fine-tune on specifically our use case. It is a very powerful tool, don't get me wrong. However, there are a lot of considerations when looking into fine-tuning. First and foremost is that data leakage. You have to make sure that when you're fine-tuning your model, you're not including information that you really don't want, especially trade secrets. The second is ensuring that model quality and accountability of your model is baked in. If you pick a wrong data set, that actually might skew everything. I'll talk a little bit to that later. And finally, there's always the cost factor. Fine-tuning is not cheap. You have to host your own model, and you lose a lot of those economies of scale. Today, we'll talk a little bit about something that in the technical arenas, we call catastrophic forgetting. When you're fine-tuning, what you're doing is that you're taking an additional data set and you're putting it on top of what the LLM has already been trained on. And you're actually adjusting what the LLM attributes to each concept. So let's say the word Roger, that's a person's name. And it associates with, oh, Roger is a person in the UK who does whatever, right? But what if you train it on Mr. Rogers? Throwback, right? And Mr. Rogers is now a kid's cartoon show. So if you ask how old is Roger, now the LLM is confused. And you'll see that in this image here, during catastrophic forgetting, sometimes when you throw data into the LLM, it actually makes it worse, not only at doing the task that you wanted to do, but at what it was trying to do originally. And that's one thing that you have to be very careful about. So you really need a team of folks that can benchmark this capability and ensure that the LLM is performing to your expectations and doing the tasks that you require it to do. But choosing that data set also comes with another risk: accountability. You'll see all these articles about how AI has given either misinformation or has actually been extremely biased. So you'll see that AI is actually surprisingly able to discern race and gender from things that you probably don't associate with race and gender. Maybe you'll say that that's actually more accurate and it's an identifier that you didn't know about before. But in our other decisions, we don't want to be making decisions based off of these protected classes. This is an example of what Bloomberg did some research on, and the images generated with generative AI follow skin tone profiles. Different occupations are usually overrepresented in certain races than others. You'll also see that genders are often misrepresented in different generations of artificial AI images. So when picking your data set, that skews this bias. If you have a lot of photos of a certain class, or maybe you have a lot of photos of dogs instead of cats, then your LLM is more likely to generate dogs than cats. And to touch on cost very quickly, is that costs come from a variety of different places. It's not just the model hosting, it's the data labeling and training. That data that you need to feed into the LLM often requires more structure than it does for if you were to leverage the LLM to query your data. because the LLM can read over everything and react to it. When you're fine-tuning, you need to make sure that you've labeled what your data is, what the expected response to that data or that query over that data is, and you need to have enough entries for every different situation. So there's a lot of manual work in that 70% that makes up data labeling and training. And of course, finally, is model maintenance. What happens when the LLM provider comes up with a new model? How will you benchmark it with your fine-tuning? Will you redo the fine-tuning? Will you perhaps not upgrade the model and then have an outdated model that performs differently? What if you're combining LLMs, right? Now you have an outdated model and a not so outdated model. How will they work together? So there are a lot of questions when it comes to fine-tuning, and there are a lot of hidden costs, which is why we love the approach of RAG, the Retrieval Augmented Generation.
So Alex just talked to you about complexity, privacy, the amount of engineering effort it actually takes to fine-tune these models and make sure that they're performing in the way that we want them to perform. But Appian has spent the last year actually implementing another advanced technique called Retrieval Augmented Generation, or RAG. And in short, RAG is this methodology that gives us the capability to give our private data to an LLM and have it use the data that we want it to use to answer questions. So in fine-tuning, you're giving an example set and a training set, and you're training against this, and you're trying to benchmark it and trying to get it into a little box of functionality that you want it to perform. But the overall thing that we're trying to solve for, right, is these large language models are trained on internet scale data, vast quantities of data. And we have our own data with our own information that we want to source the answers from, not from this internet scale data. So the naive approach, right, is you have a prompt and the user asks a question and you're just going to feed it all of your data, right? LLMs are great at looking at vast quantities of data, analyzing it, and then looking at the user's question and matching it to our private data to answer the question. That's the naive approach, but a couple of problems with that, right? First of all, cost. I'm not sure how familiar you all are with the cost schema that most of these providers are using at this point, but it's token-based pricing. So a token is approximately one word, and that means that all the information that you send to it, if you're trying to give it all your data, that's going to be prohibitively expensive. Second of all, we got security. So you only want to feed it the data that the users actually have access to so that when it responds to a user, it's not responding with things that the user shouldn't know. And Alex actually mentioned that with fine-tuning. You don't want it to respond with a bunch of information that the user doesn't have access to themselves. And third of all, this is brand new technology. There are fundamental limits to the LLM architecture at this point. LLMs can only fit a small subset of data into their prompt window. Right now it's at like 128,000 tokens. Most models, most top-notch models have that ability. Gemini just launched 1 million, but we don't know how far we can scale this. There's only a small subset of data that we can provide it so that it can answer our questions off of it. So then how do we get AI to talk to our data? Well, with RAG, what you can actually do is a user asks a question, and we're going to match that question to our data set to find the most appropriate sources that we want to feed the LLM. So semantically searching our data, finding the most relevant data to that question, and then feeding it to the large language model. Now it can answer based off of that subset of data instead of the entirety of the data itself. And that addresses all of these concerns. So Appian has an amazing culture of research and development. And basically, last year, RAG came out, right? There was a bunch of academic papers on it, a bunch of demos, and we started hacking immediately. And we found that we actually came up with a pretty good solution, and we launched it to the app market. It's called the AI Knowledge Assistant. AI Knowledge Assistant, it's available on the app market today. What you would have seen is an advertising company has a brand new ad, right? It has some language around it. We've got some regulation about what language we can say in the state of Virginia. And basically what we're going to do is ask the large language model to answer the question of, what language should I not say in advertisements? And it says pretty much immediately, and it gives you the source for it of, hey, I can't say the word stop and danger, and that seems to be in our ad, so we probably shouldn't go ahead with that. Next up, we have So we actually released this to customers. We've got a lot of fantastic feedback, and we actually implemented our own version of this called Document Chat that's actually going to be coming in 24.3. And this version right here is going to be out of the box in the Appian product, built off of private AI. So we're going to ask a similar question. What are some characteristics of advertisements that are misleading? And it's going to give us the documents. It's going to give us the areas that it actually sourced that information from and answer our question appropriately. Next up, we've been hearing a lot about AI. There's a lot of hype around it. I'm not sure if you're familiar with this video, but let's play it real quick. Hopefully the audio works.
AI, generative AI, generative AI, generative AI, AI as AI, AI. It uses AI to bring AI.
So the elephant in the room is there has been a lot of talk about AI this past year, maybe a bit too much. But what I'm here to say is that it's not just hype. NFTs came out, everyone was talking about NFTs. They're kind of stupid. AI is not stupid. There's a lot of promises going around, but Alex and I are both engineers, and we're very excited about the capabilities that we're able to deliver right now and in the future. So Appian has been releasing AI very fast, very rapidly, and it might be a little bit confusing, but today I'd like to kind of demonstrate the differences between what we released last year with AI Skills and the 12 new models that we released today called Gen AI Skills. So with our mature models, right, these are algorithms actually trained on your data. These are mature algorithms that have been in the industry, have been benchmarked, tested, and you can actually train them on your own data to do certain tasks. And right now, we have 3 models. We've got email classification, document classification, and document extraction. And these are custom trained models that can be benchmarked and implemented by anyone on your team. You don't need any machine learning experience. But this past year, as we all know, there has been tremendous advances in generative AI, and we've developed actually 12 new Gen AI skills that we released yesterday. And these are just as easy to configure as the previous set of features, but they have enhanced capabilities like PII detection, summarization, generation, this native prompt builder that you can basically create any Gen AI skill that you want yourself. And actually, Alex is going to show you how easy it is to configure within your application.
Absolutely, and like Julian said, AI has been around for a very long time. We've moved from machine learning into generative tools. And part of the differentiation between them is that traditional AIs, or what we're going to call traditional today, are deterministic. Generative AI is a different approach to that. We're generating and statistically predicting what it should respond with. And that results in very creative responses to all these different queries that you have, and also an ability to understand your natural language in ways that were not configurable for traditional AI models. But it really does require a combination of the two to really bring power to it. Generative AI on its own, because it's not deterministic, is extremely hard to benchmark, bringing it back to the point that we had before, where now you need to know what part of that experience that you want your user to have relies on that generative part. What part of that experience, when providing those information, providing predictions based off of the user's previous experiences, for example, those have been around forever. Netflix, for example, still uses their traditional ML to predict what movie you want to watch next. Same thing with YouTube, right? So it's this combination that truly is the future. And we fully embrace that here at Appian. This is an example of our email classification, where this is a traditional model that classifies what type of email it is so that you can integrate it into your processes and automatically route which sub-process you would like to process this email with. So maybe certain emails need to be routed to an individual for a review. Or maybe certain emails need files extracted to make it easier to review or to approve at a later date. And then how can we combine that with something that's more generative? In this case, this is document extraction, where we're able to take certain fields in a document that perhaps was in that email and determine what data structure we can shove that in so that we can present it in the best possible way for the end user. And you'll also see right here is something called Prompt Builder that we've worked on. And that's something very important. You've heard yesterday that prompt engineering is a new role that's becoming more and more popular in a lot of spaces because it's so difficult to tune your generative AI to actually behave in a way that you expect it to. Prompt Builder helps make that a little bit more low code and gives you a little bit of structure. You don't need someone to sit with you to guide you through how to write that prompt. Maybe there are certain wordings that actually make the LLM perform better. That's baked in to our low code tool. Maybe there's some terminologies and ways that make the AI reason in a certain way. That's also baked into this tool. So this tool really brings those best practices when creating these prompts directly to you so that you don't need to know that information when you're first playing with that Gen AI, allowing you to move a little bit faster when testing it.
And finally, Appian is exploring new ways to use AI to solve traditional problems that we've been facing as an industry or not even as an industry, just as basic users of web applications. So today, if you were at the keynote earlier, I tried to show some videos. Hopefully these actually play for you today so I can show off the amazing new stuff that we're actually working on. But we all know that any website, the internet itself, is really comprised of three things. It's comprised of data, interfaces, and actions. Data, it's all the information you care about, right? It's all stored into databases. Then interfaces present it to you in a compelling way so that as a user, you're actually captivated by what you're seeing. And then actions can either modify that data or take you to a new interface. This is the basis of the entire internet. This is how all web applications work. And we're actually exploring how to use generative AI to take it a step further. Because really what you're trying to do when you navigate an application is get some functionality fast, right? I want to just be able to ask my computer to do something and have it either pull up that interface or change that data or fill out that form or take me to where I want to go instead of having endless tabs and navigating through a prescriptive set of links to get to the interface I'm going to. Think about iOS settings. When you want to change a setting and you're just clicking through all those intermediary interfaces, or you're on an Instagram page or a Facebook page and you're trying to just find that one person or find that one setting, but you're having to click through all these things, open up all these new tabs, instead of just asking like, hey, I want to change my privacy settings so that people can't tag me in certain things. So first of all, we're going to show off interface navigation. This is a brand new concept for our AI Copilot. This is going off the satellite management company that we showed you on stage earlier. Right now, I have plenty of reports, but they're scattered across different applications, different interfaces. As we know, Appian has a ton of objects, and they're great. You can build a ton of applications on Appian. That's great. But I just want to see my data instantly, and I know what I'm looking for. So why don't I just ask for it? Next up, we have our data, right? We found our interfaces, and now we want to chat with a specific record type. So right now, you can only build, the developer themselves can only build prescriptive filters and sorts for how they think an end user wants to navigate through their data. But as an end user, right, I want to be able to just ask my computer for a certain query and have it translate my natural language into the information I want to see. So right now I'm filtering by a maintenance record and I'm sorting by year, and I'm sorting by power level and year. And instead of opening up all these record views as separate tabs, I can just view and compare all my data from one single display. So now I can actually look across my data and not click to separate tabs and separate windows to find the information that I want to see. And finally, I want to do some action on that data, right? I found what I want to see. Now let's create a support ticket, assign it to the Power Systems team, and attach some information from the task list that kicked off this entire thing. And it can actually use the context of that conversation to fill out that form for me. And then we can go even further and take all that record data and match those record fields to document templates to generate the documents that we need for government review or for any regulatory, and basically any reason that we want to generate a document. So AI, right, can actually match that information to the documents, and then we can edit it within Appian itself. So this is AI-powered navigation, right? It's faster to use. You don't have to click through intermediary interfaces. The developer, right, is the one guessing how an end user wants to use their application, But the end user traditionally really doesn't have flexibility in how they actually use it. So this is faster to use because the end user can just type what they want to see and have it instantly pulled up. It's a more natural navigation. You have a clear information flow because you can just ask your computer for something, it can pull it up for you. And it's actually workflow first. So instead of actually saving any interface as a bookmark tab, I'm sure we're all familiar with browser bookmarks. We have loads and loads of them in different folders, and we have to organize them ourselves based off different applications. But now we can just save that entire workflow. Say I go through my satellite maintenance workflow every day. Now I can basically create my own dashboard of data, interfaces, tasks, and just pull it up in one click, all within Appian. And then lastly, this is all auditable. This is great because now I can see how I use my Appian application and share those workflows with other people so that my entire team can go through the process just as I would. So this is a new concept for an Appian Command Center, an Appian Browser, an Appian Copilot. So Appian provides this as a foundation for practical AI. We're trying to think of ways that we can actually deliver real value, think differently about how we want to build business applications so that you can actually get to the information you want to see, put AI in your processes in ways that make sense, in ways that are auditable and secure, and not have to deal with all the engineering overload of having to create custom models and fine-tune and maintain these advanced systems.
And now we'll open up to some Q&A. If you have any questions, we'll have a mic coming around. We have a question up front.
Hello. Can you hear me?
Yes.
Yep. Okay. So thank you so much, first of all, for a nice presentation. And what I would like to get your inputs also, in everybody's talking of AI. How does this model differentiate itself with what, say, Google may offer or Microsoft may offer? And how does this eventually transform? Because this technology will keep on evolving.
Mm-hmm. So at the end of the day, a lot of this actually lives on top of the LLM itself. So we differentiate between what is an AI and what is the large language model that backs it. So in many cases, these reasonings and these navigations are on top, are completely agnostic to which LLM they use, as long as LLM meets certain parameters. So right now, say you're using Google, or you want to use Claude and Anthropic. Let's say you want to use OpenAI, for example, right? You can choose which model is backing your queries, and it can actually even extend in the future to multiple different models.
To actually build off of that too, traditionally, right, AI is supposed to solve a specific problem. So for our AI skills that we released last year, right, they're very specific tasks that they're trained to do. Obviously, with generative AI, they are starting to be not as brittle. They're starting to solve different functionalities just based off of how you prompt it and how you interact with it. So it's really it's turning from specific functionality that the developer is building to more of an infrastructure. So large language models you can think of as something as fundamental as like a database. It's the infrastructure on which functionality is built. So what Appian is doing is like, okay, if this is infrastructure, how can we actually build the functionality on top of it to provide real value? For example, the interface navigation, that's using the AI just to make different calls, pull up different data, interact with different interfaces and actions. And this is all built on top of AI, or the large language models. Mm-hmm. And the providers themselves are the one that are competing to make those models more capable, be able to reason better, be able to plan better. And where businesses differentiate is what they actually build on top. So we're actually like building a large platform of different functionality and features on top of LLMs.
And to demystify that even more, right, is that even these providers, what they're providing as a model service is actually more than just the foundational model. They are wrapping in those guardrails, which is a completely separate model, checking your inputs to make sure that there's nothing harmful. Or maybe it's an additional model to process images that you upload along with your text data. So everything nowadays is this, layering upon layer of these additional features. And the differentiation comes, how easy are these features to implement? Do they fit your needs? Are you able to control it? And that configurability is key.
Hi. How do we go about extending these newer capabilities that you've rolled out, the 12 new AI models on top of the solutions, some of the solutions we're already building, we're offering it to the market? Is it in your Appian AI designer skills, or how do you go about? Because there's some fantastic things you're doing, but we want to make sure it reaches the customers and you're able to extend this.
Yeah, of course. So all these features are coming in 24.2. There's a couple coming in 24.3 that we can get into more specifically. But basically, with Appian, you can think of two different buckets. Right? We have our AI skills, and these are specific pre-built functionality that you can plug into any process model, any process, and that you can find as an object in the designer itself. So you click on the AI skills, and it has for documents, for text, for emails, all this pre-built functionality. And then next is Copilot. And Copilot is basically our chat-based design. So this is chatting to create interfaces with our form designer that we released last year. This is chatting with records, with our records chat. This is the documents chat that we just released, as well as the documents chat that's on the app market today, which you can use. The docs chat that I showed you in the video will be coming in a later release to the platform itself. But basically, two buckets. One is for process models, and the other is for chatting. And you can use them basically by either putting them in an interface and putting them in a process model.
Julian mentions the key part there is the process model. Now that's how you really extend it, is that you can create your own processes and flows that these would go through. And as a matter of fact, you're not limited to using AI just once. You can say, I want to take the input, use GenAI to parse that input and determine what the intent is. Now I determine which AI I want to run. Do I want to run an RPA to pull additional information? Do I want to run IDP and our document classifier to find out more information about an attached document? You decide how that goes, or maybe you want someone to approve, hey, you can have this information. And then it goes back to the AI. You can feed it back to whoever you want. You can feed it back to the AI, and you can configure, okay, now you can give responses in this field. These are the data that you can pull from when giving that response. So that flow is where you really control it.
Really fun follow-up question there is, how do you train the end users? Because when you're giving about data interfaces, the end users, the application would also need to be trained to be able to prompt the right things. Because we've tried in the past, I mean, as you rightly said, if it's not properly done, it comes up with all sorts of unnecessary information, or sometimes it doesn't work.
So there's a differentiation between the end user prompting it and the designer prompting it. So when you're a designer and you're designing your GenAI, generally the prompting happens there, and that's where our prompt tools happens, right? The end user in practice should really never have to prompt. In testing for AI reasoning, for example, a lot of the examples I showed this morning are bare bones, dumbest possible way, and I used the wrong terminology. So I actually purposely used the wrong name for features and the wrong name for fields because I wanted to simulate being an end user who doesn't know what I'm talking about at the end of the day. And the GenAI, because it's creative, is able to look up your records because it has access to all your data. Now it can look up and actually it can verify. It can say, hey, this record is what I think you're talking about. I'm going to check it. Oh, it doesn't have this field. Let me check this other field. And so it's completely in the back end. The AI is able to self-correct and self-heal to best understand and fulfill that need. So at the end of the day, you really shouldn't have your end user needing any amount of prompt usage training.
Just a quick question going back to the language models. I believe you guys are currently using Claude, right? Claude 2. So is that going to be for customers in the future? Will there be a choice of what models we want to pick?
Yes, because we're so closely tied with Amazon AWS Bedrock, and we have that new partnership announced yesterday. We work very closely with them to make available all the different models that AWS has access to. So you'll have all that in that FedRAMP or very secure environments, and it'll come with all the bells and whistles.
Yep. And we're completely built off of Bedrock right now. So for example, Claude 3 Opus, which is basically the top-notch language model at this point, just beat GPT-4. That's going to be available on Bedrock, on Amazon, which it means we're going to start using it. They also released function calling with Bedrock, which we don't have to go into the technical details, but this brings in a whole new bevy of functionality that we can actually produce for the end user.
And actually goes beyond that, right? Because we do have integration that you can create integrations object in low code in Appian. And those allow you to use OpenAI if you wanted to, or anything with an API. So you're not limited to just the Bedrock. Bedrock is just the easiest possible way. Everything's integrated. We provide these guarantees that AWS provides us. And if you want to stray from that, if you want to really build something truly custom and truly to your needs, you're welcome to do that as well. Any other questions? All right, I think that's a wrap. Thank you, everyone.